So this is one breadboard example I'm giving you. So what people do, people just put various ICs on breadboard and they connect it together and see how it is working. So, but this is a very vague way. This is not a standard way because there might be a lot of noise added in due to these long wires. There might be a condition that the components are not properly connected or ICs are not properly connected. All right. So we generally, if you see your electronics 101 course anywhere in your undergrad or masters, people start building the circuit like this on hardware actually. So so from here I will be talking about the hardware thing. Okay. So that's how you can see if you want to build a bigger circuit, if 5 6 IC, it will completely a mess, and it is really difficult to debug. But we start with this. So to avoid this thing, what we do, we go to one step further. We do a PCB thing. We solder our chip on PCB. So I have shown two ways. One you can see. So this is the simplest example where people are still using wire, but they're soldering it out. So it is ensuring at least the connection will be there. Okay. Another thing, what people did, people just made the tracks. You can see those tracks. Yeah, these tracks are even better. Okay. So what is the solution? So there is one solution. Why not we make a chip? If somehow we can make a chip, we can avoid all these problem of wiring and noise and all that. So what is a chip? What is an integrated circuit? So integrated circuit basically we design at a very low scale. Very low scale means size is very small. So we are designing. You heard these nodes: 180 nanometer, 65 nanometer. So this is generally called the channel length of a single MOS. Not appropriately, but loosely defined channel length. Okay. So you heard these node 180 nanometer, 65 nanometer. So in 3 nanometer, people are building lithography, and by the end of year 2022, they will start fabricating 3 nanometer also. Presently, 5 nanometer already fabricated. So this pad on which I am writing, it is developed on 5 nanometer by Apple. Apple basically get their chip from TSMC. So TSMC developed it on 5 nanometer. Okay, so next node people are targeting 3 nanometer. All right, so that's how we are reducing the mass really. So the summary is we make really tiny components on chip. Okay, Eh, maybe at this area, say 1 cross 1 area, we can accommodate millions billions of transistors. Okay, so that is the advantage of integrated circuit. And there is another advantage, like for example, you have seen this board. So these ICs are digital, but take a hypothetical case. This is a suppose this is a receiver antenna. After that, LNA is there, and then mixer is there, and local oscillator, and another digital processing elements are there. So so what will you do? Suppose you have different IC. Suppose you have LNA IC, you have mixer IC, you have mixer IC, you have a local oscillator IC, and you have another digital IC. So if you want to make that receiver architecture on breadboard, so matching will be one problem, because at that time, if you are coming out of chip, you need to match it at 50 ohm. So 50 ohm is one standard. Then again, you are going back to chip. You have to ensure matching 50 ohm here. And similarly, with each IC in RF IC communication, you need to worry about the matching. If the dimension is more, suppose you are designing something on PCB itself, so you need to worry about matching. If you are coming out of the chip, you need to worry about matching. But on IC, if you are making, and the frequency is also not that much large, so you need not to worry about the matching. After LNA, you can directly make the mixer without ensuring the 50 ohm match. Okay, so then because the dimension is very small, so that is the advantage. Okay, so again, we are clear what is integrated circuit. Next question is, so we generally call this IC, no? What is this inside? Can someone tell me? Can someone tell me the name of this? Okay, this is called die. So these, so we actually make these dies and then we connect through bond wires. You can see those wires, and these wires are connected to the pin. So that's how this thing is called package. Okay, this is called package. Main IC, main integrated circuit is this, and we call it die. So how we make this IC? There is a process. First, we design the schematic. So we design the schematic on some tools. For digital people, it looks something like this schematic. So it has a gate level thing. So there might be some mux or header or something, and they are connected. We write a very low code and we get those kind of stuff. And if we design the layout of digital IC, it looks something like this. Can anyone design this layout by hand manually? Yeah, it will be very difficult. No one cannot, because there are millions of transistors in there. So these are designed using tools only. So tools only do the placement, routing, and all those things. All right, but in analog, we have limited number of transistors. Okay, so we do design the IC manually. So this is one example. One of my senior has designed this IC in the lab. So here you can see. So if you see, these are the inverters. So this is the inverter chain. Basically, this is a clocking circuit. So this lower one. So this this is a layout, complete layout of that chip which I have shown you. These are those pads which we connect through bond wire. Okay, so and these are rails, VDD and ground rails. So we need a lot of VDD and ground when we are making a complete IC. There are a lot of blocks, and it looks something like this. So this is one layout design, and after design, we fabricate this, and it looks something like this. The right one has a metallization. You know, everything is converted through metals and all. Otherwise, everything is at place. If you observe, so that's how we do. So the process is simple. We start with an idea. For an idea, we sit with a paper. We read some research paper, or we develop something mathematically if required, or something. Then that idea we simulate. After simulation, if we get a good result, we go for tape out. For tape out, we need a layout. We design layout, and then we send the layout to foundries. If you see that die I showed you earlier, so it looks something like this. These dies. So they deliver after tape out. They deliver these things. Okay. So the same chip they deliver like 20 or 30, because sample might get damaged while testing. So you should have sufficient number. Okay. So how tiny it is? If I compare with a 2 rupee coin, so it is this much of tiny. Okay. So it's not packaged. It's a die only. So if I package it, so it will look something like this. This is a packaged one. Okay, and this is actually these are external connection, because we require those kind of signal to be fed and take the output from these kind of things, because it's a RFIC application. So that's why we connected through these things. So maybe in analog IC it is not required, and or, such kind of connections are enough. You can see some clock is there. So digital IC might connect something like this. So basically, these IC is a combination of all. Most of the part is digital, some analog, and some RF if it requires radio to send and receive signal. Okay, so this is PCB. So that's how we develop.